Hey, hi everyone. Good morning. So I'm Rudraksh. I'm an AI engineer at CS, and I am twice Google Summer of Code contributor, and I love cloud-native AI. So today I'll be presenting about building privacy-first vector search pipelines after containerizing OpenSearch. So how this is going to happen and how we are going to containerize the OpenSearch vector database locally on your system. So I'm going to walk you through this entire setup and pipeline. So before we jump into this very interesting process, I would like to introduce my co-speaker who couldn't travel here due to his visa delays. He's Satyam. So he works at Devtron as software engineer, and he's also a Google Summer of Code contributor along with me, and he's also a CNCF ambassador. So before we jump into the the process of containerizing OpenSearch and running it on your premises or on your local devices, we should understand why exactly we want to do that. So the state of the current AI search. So we all been using this proprietary LLMs, proprietary APIs, and we are passing our data to these LLMs without any second thought. So let's say you are using enterprise OpenAI API or Claude or even Gemini, and even we as a users, we don't understand the significant concerns when it comes to it. But when a big firm like a consultancy firm or a pharmaceutical firm who have very important data and they are using such LLMs, they might be logging your queries or storing them or using them to retrain their models. So there is always a risk with it. And there are hidden exposures and compliance risks. So we can definitely avoid that with open source LLMs and set up everything locally and set up a privacy-focused vector search pipeline. So definitely, so everyone is running after the cloud APIs and ignoring the privacy. So here's a meme on that. And we can have something smart like ChatGPT and private like SSH. So that will be your private thing on your own system. So why exactly I'm choosing OpenSearch apart from other vector databases out there? So because OpenSearch provides the hybrid search plus text search, and apart from the vector databases in the market, like let's say we have Pinecone, VV8, Melvus, pgvector, and Quadrant. So OpenSearch is something which has pretty much everything combined together, which will help you build very scalable and really useful pipelines. So it's distributed and it's open source and it provides GPU support. And as in the previous talk we saw, like Prashant walked us through how it performs the hybrid search and how the BM25 implementations can be pretty easily implemented in the OpenSearch itself. So I think that's where OpenSearch stands, and we can leverage it for this privacy-centric vector search pipelines with the open source LLMs. So more to that, the system architecture that I have set up and we will be going through further with the demo is we will be having a local RAG pipeline where documents, any document in formats like PDF, docs, or TXT, you can upload. And essentially, what we are doing is we are having a Streamlit-based interface and application layer where is a Retrieval-Augmented Generation system is located, and I'm using LM Studio, who are the providers of the embedding model, and I'm using Qwen3 4B as a local inference LLM in the process. And for the vector database, I have pulled up a OpenSearch container locally, so I'm using that. And on top of that, I'm performing a KNN, K nearest neighbor, and HNSW is another algorithm performing the vector search pipelines in the OpenSearch. So I'm using that. So I'll walk you through how it is a privacy-focused stack. So here, no cloud is involved. Your Docker is completely isolated on your premises, and there is no data transmission happening outside your machine, as well as it's fully operated on a single system. So if we go further, the first step in the process would be just pulling down your OpenSearch image. So you will be just doing a Docker pull, OpenSearch project / OpenSearch latest, and from the Docker's registry, you'll be getting this latest OpenSearch container image on your system, and you will be spinning that up. And this is our stack. So OpenSearch is providing the vector database, LM Studio for this embeddings and large language models. So next to that, yep. So we can cover this up in the demo ahead. And first thing would be for us to create a index of our documents. So we need to index whatever the documents we have into the OpenSearch containerized vector database. So I'll walk you through this structure. So here exactly you can see this is a very simple index JSON that I'm having. So here we are setting up the algorithm that we want to do. Here you can see that in the settings I'm putting index as KNN true, then I'm setting up the parameters as 100, then I'm adding mappings, and like the type is KNN vector, then I'm adding dimensions as well, then method is HNSW, and again, so we can add a bunch of things here as well. We can even configure metadata and all those things. I have done that in my demo. I will walk you through that next. So this is something, a successful screenshot from when I ran my pipeline and indexed few documents. Then I guess we can directly jump into the demo. So I have recorded the demo because I didn't want to run into issues while running a live demo, because my Mac will, it won't work as expected, because I'll be running a LLM locally, and I already had few issues while running it. So I have a recorded demo here. I'll walk you through. So first of all, what I'm doing here is I have loaded the embedding model, which is like pretty good ranked. I'm using Nomic Embed Text v1.5 and Qwen3. So these models are performing pretty good for me, even when I run them locally, and the first time to token is also really good. I'm using MacBook M4 Pro with 24 GB of RAM, and yeah, so it's working pretty fine here. So now both of these models are loaded into the LM Studio. Now, okay, so here's the interesting part. So LM Studio provides you an OpenAI compatible API, which will be served on this localhost 1234/v1/models portal. So you can essentially use this API to leverage and build your privacy-focused vector search pipelines anywhere. So this is a very small-scale POC, but if you have enough computation, this can be converted into a very production-grade system as well. So here you can see, so your API endpoint is ready, and these models are being served. And now, next to that, we'll jump into the code base, and I have a index document to dump into the index. So it's very popular, attention is all you need paper. So I'm using that to index into my OpenSearch vector database. So here you can see my ingest document.py is my ingestion script. So here I'm importing OpenSearch and its helper methods from the official OpenSearch library. And you might be wondering why I am using OpenAI here. We are using only local LLM. So actually, I'm not using OpenAI for just standard, like some schemas or something. I have just imported it. And here you can see, even in my .env, there is no OpenAI API key or anything. I'm just using locally hosted API endpoints from these LLMs and LM Studio itself. So I have OpenSearch host. So on port 9200, where my actual container is running for the OpenSearch, and the OpenSearch index is where this demo_pdf.pdf is being used, and there is like LM Studio base URL, as we just saw that that's where the models are being served, and again the embedding models are being served here. And I have configured the top K results, so to get some decent chunks picked up from my rack pipeline itself. So let's move ahead and see how exactly the ingestion is going to process further. So here, next to that, I have my document ingester class. And here you can see I have an extended JSON that I'm using for this ingestion. So again, I have set up KNN as true here, and I have this KNN vector. Then again, in the parameters, I have set up some parameters. And here you guys can see, previously I mentioned, you can also set up some metadata while ingesting your documents. I'm using a metadata part in this ingestion pipeline. So if we move ahead, so I have like the rest of the helper functions to read documents into different formats, including docs, text, and yeah, so it's just a straightforward ingestion pipeline. I looks like okay. All right. So yeah, so now I will be running my Docker container. So I'm doing Docker PS to check on this port exactly my OpenSearch container is running. Here you can see. Okay, so that's how you will get a confirmation that you have successfully pulled and spinned up your OpenSearch container. So now, what next will be is I will be running a ingestion on top of this demo PDF that I have. So, okay. So I'm using UV here. So UV is a Python virtual environment management that is written in Rust. So I'm using UV run Python ingest documents.py. So okay, I'm activating my environment. Okay, awesome. So right now, our single PDF, it is a single PDF, so it is ingested very easily into this vector database. It didn't take much time, so the ingestion pipeline is complete right now. And if we move ahead, we will see that the ingestion is done, and now, yeah, here we are on the demo screen. So I have built a Streamlit UI here. So in the Streamlit UI, you guys can see it's like I have some document retrieval settings here, and I am showing like like I can initialize my rack pipeline from here, and next to that, the processes will run. So I have added a status check flag for this, whether LM Studio is running or not. And now if I go, both the services are running. So we can actually chat with this document, and our vector search pipeline is running right now. So even I can upload some documents and ingest. So actually here you can see I have uploaded my current slides as another document from the UI. So in our vector DB right now, we have two documents, which is one, attention is all you need research paper, and my slides. So now I can just quickly jump onto the query, and now I'm asking a question, where do I work exactly? So let's see. So here you can see the retrieved context is it's being picked out of these two documents, and here it has answered it correctly that I work in CS Associates, and it has given some relevant document which is the reference one. And now I'm asking another question: what are transformers? So this should be picked up from the research paper, because the paper is all about transformers. So yeah, so it is being picked up from the transformer part, and here you can see there are citations as well, and we have query history as well here as a part of this process. So yeah, that was pretty much about the demo. Okay. So if you want to have a link to this repository, you can just quickly scan this QR code. I have a very simple code base, so you can always get that from my GitHub. And now, yep. Okay, so here you guys have noticed, like I have a vector DB, and I have ingested some documents, but there is something missing into the picture. That the context is everything, right? The context is the most important ingredient in today's agentic AI systems. So if I want to have more context, so I can actually use MCP server and get some more relevant data. So that's where I want to give a shout out to the OpenSearch MCP project. So here's the project's link. So the project is under development, and they are building some awesome features out there. So probably I haven't integrated one of those newly coming features into this demo, but yeah, you guys can check out this MCP server as well, and MCP servers are awesome. So yeah, so as I said, this is a very small scale POC, and I have been running this on my MacBook, and I couldn't even show the live demo because I was afraid that it will just disrupt everything. But now if you want to scale something like this, so that's where probably you can use some cluster like NetApp, and you can actually spin one of their clusters. And they have an OpenSearch cluster out there. You can just go ahead and build your OpenSearch container, and you can monitor that container out there, and you can actually get some credentials from there and use that to set up similar vector search pipeline. And this is how you would be able to use these self-hosted models there from Hugging Face and all, and you would be not in a position like me, and you'd be able to use all of those pretty seamlessly and run a live demo maybe. So here you can connect with me and my co-speaker who is not here today, so on LinkedIn. Yeah, if you have any questions, I would like to answer. Sure.
We need to use OpenSSL when you use Docker. During the demo,
sure.
You saw you are not prepared to that. There was the line, the OpenSSH, what is, I don't know exactly what it is. But usually once you prepare to use that line, which library do you want to use for that?
So in the code base?
Not move to next page. To the demo video.
Okay, demo video.
I would like which part is that? I think it's maybe 2 or 3 minutes.
Okay. I can actually open Codebase if you want that.
Do you mind if you ask to open the code from this import part?
Okay, import part. Let me just do that. In the ingestion import.
Sorry, now I'm confused.
Here.
Oh, there.
Yeah.
Click on the line 12. You say you're not prepared to use the OpenSearch
Yeah, OpenSearch Pi. So this is actually the Python package listed on the Python pip index. So that actually provides the OpenSearch Python libraries to you to build this services out of OpenSearch containerized vector database.
Oh, thank you.
Yep. So here, actually, I'm importing OpenSearch and helpers. So these are classes that I'm importing and leveraging this into the pipeline. So there are a bunch of other features as well. So if you are building a very complex pipeline, you can use that. And yeah, they're providing lots of things, and it's open source project. So you can definitely check that out as well.
Thank you for the answer.
Yep. Thank you.